Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to work on some easy word problems involving fractions. In case you're wondering, this is my third video on fractions. About 7 months ago, I uploaded my first video, and that was a 30-minute review of fractions. And about a week ago, I uploaded a video in which I worked on some very challenging word problems involving fractions. Ultimately, my goal is to have 4 of these videos on my channel, and if you watch all 4 of them, you should have no problem dealing with fractions on the ASVAB. In order to get the most out of this video, though, I want to encourage you to make an effort to work out all the questions on your own. That is to say, after I read a question, you should pause the video, attempt to work it out on your own, and then resume playing the video to check your solution. So all that being said, let's go ahead and get started with today's video. This first question says, in the first 2 hockey games of the year, Vladimir played 1.5 periods and 1 3/4 periods. How many periods did he play in total? So as I mentioned, all these problems in this video are going to require 1 or 2 steps to solve. And for this one, we're simply going to add 1 1/2 to 1 3/4. That is to say, we're adding 2 mixed numbers. Again, he played 1 1/2 periods and then 1 3/4 periods. We want to figure out how much he played in total. So in this case, as you can see, we're adding 2 mixed numbers, and in order to proceed, we want to convert these mixed numbers to improper fractions. And the way you do that is like this. You do 1 times 2, which is 2, plus 1 is 3. So this becomes 3/2 as an improper fraction. And we do the same thing here. We have 1 times 4, which is 4. 4 plus 3 is 7. So this is 7/4. As you may recall, you can only add fractions if they have the same denominators. In this case, we have a denominator of 2 and a denominator of 4. So our goal here is to rewrite either one or both these fractions such that they have the same denominators. And this is pretty easy to do. 2 and 4 share a common factor of 4. So we're going to rewrite these fractions such that they have a common denominator of 4. 7/4 already has a denominator of 4, so we're just going to copy that one down. To write 2 as 4, going to multiply it by 2, and we're also going to have to do that to its numerator. 2 times 2, of course, is 4. 2 times 3 is 6. And now that these fractions have the same denominators, we can simply add them like this. Again, the denominator does not change when you add fractions, but you just add the numerators together. So this becomes 6 plus 7/4. 6 plus 7, of course, is 13/4. Now, you may see an answer given as an improper fraction, or you may have to convert your improper fraction back to a mixed number. And again, in case you haven't worked with fractions in a while, let me explain what the definition of an improper fraction is. An improper fraction is a fraction in which the value of the numerator is greater than the value of the denominator. In this case, 13 is bigger than 4, so our numerator is bigger than our denominator. All right, so if we wanted to convert this back to a mixed number, we would do some simple long division here. Notably, we would read this as 13 divided by 4. And we start by asking ourselves, how many times does 4 go into 1? It doesn't. How many times does 4 go into 13 without going over? Of course, that's 3 times, given that 4 times 3 is 12. 13 minus 12 is 1. So rather than proceeding and figuring out what this decimal is, we have enough to write this improper fraction as a mixed number. This 3 is going to be our whole value. This 1 is going to be the numerator of our fraction, and this 4 is going to be our denominator. So 13/4 is the same as 3 1/4. And to answer this question, Vladimir played 1.5 periods as well as 1 3/4 periods. He played a total of 3 1/4 periods of hockey. So That's this one. Again, not that much work to solve this one, but a little bit easier than the problems you saw in my video from last week. All right, number 2 says Neptune completes 1.5 turns about its axis each day. How many turns does it complete in a week? So there are two approaches to this one. Again, first we have to know that there are 7 days in a week. So you can certainly do this. 1.5 plus 1.5 plus 1.5 plus 1.5 plus 1.5, and that's 1, 2, 3, 4, 5 plus 1.5 plus 1.5. Okay, so if you added all these up, you would figure out how much it turns in a week. But that said, we should realize that we can simply do 1.5 times 7. These things are the same. This is 1.5 added together 7 times, and this is 1.5 times 7. So for this one, I'm going to take this second approach. And as you can see, we're multiplying a mixed number by a whole number. So let's start by rewriting our mixed number as an improper fraction and our whole number as a fraction as well, an improper fraction. So it's pretty easy to do, as we've seen, to write a mixed number as an improper fraction. We're going to do 1 times 2, which is 2, plus 1, so this is 3 over 2. And to write this whole number as a fraction, we're simply going to place it over 1. Okay, so again, you can write any whole number as a fraction by placing it over 1. If I asked you to write 5 as a fraction, you can simply just place it over 1. Now in this case, unlike the previous problem, we are multiplying fractions. And the way you do that is you just multiply straight across. That is to say, you multiply the numerators together, which are 3 and 7, and the denominators together, which are 2 and 1. 3 times 7 is 21. 2 times 1 is 2. And as you can see, we have our result, albeit as an improper fraction. So we're going to use some long division to convert this to a mixed number. Again, this fraction can be read as 21 over 2, or it can be read as 21 divided by 2. So the question becomes, how many times does, and let's do 2 into 21. How many times does 2 go into 21? Well, 2 times 10 would be 20, and 2 times 11 would be 22. So this is going to be 10. 10 times 2 is 20. 21 minus 20 is 1. So right now we have enough to write our mixed number. Again, this is going to be the whole value of our mixed number. This is going to be the numerator, and this is going to be the denominator. So 21 over 2 is the same as 10 and 1/2. So to answer this question, Neptune, if it rotates 1.5 turns about its axis each day, rotates for a total of 10.5 times each week. All right, number 3 says Nick mowed about 3/5 of the school lawn yesterday. He mowed another 1/4 of the lawn this morning. How much is left to mow? So for this one, we're subtracting how much he mowed of the lawn from the total lawn. So there's one lawn to mow, and he mowed 3/5 of the lawn yesterday and 1/4 of the lawn today or this morning. So for this one, we're going to do subtraction involving a whole number, a fraction, and a fraction. Again, the very first thing you want to do is rewrite this whole number as a fraction by placing it over 1. So this becomes 1 over 1 minus 3 over 5 minus 1 over 4. And as was the case when we added fractions, we have to have the same denominators in order to subtract fractions. So we're looking for a common factor between 1, 5, and 4. That's pretty easy to figure out. Again, both 5, 4, and 1 all go into 20. So we'll go ahead and rewrite these fractions such that they have a common denominator of 20. To write 1 as 20, we would multiply it by 20. So we're going to do that to its numerator as well. 1 times 20 is 20. So as we can see, 1 is the same as 20 over 20. To write uh, 5 as 20, we're going to multiply it by 4. Again, 4 times 5 is 20. And we're also going to do that to its numerator. 3 times 4 is 12. Likewise, to write 4 as 20, we're going to multiply by 5, and we're also going to do that to its numerator. 4 times 5 is 20, 1 times 5 is 5. And now that these fractions have the same denominators, we can go ahead and make one big fraction like this with a denominator of 20. And we have 20 minus 12 minus 5. Um, 20 minus 12 would be 8. 8 minus 5 is 3. So this is 3 over 20. So he has 3/20ths of the yard of the school's lawn left to mow. So that's this one. This is a simple case involving the subtraction of fractions and whole numbers. Number 4, as we can see, says a bag contains 10 3/4 cups of almonds. A serving of almonds is 1/4 cup. How many servings of almonds does the bag contain? So for this one, we're going to do 10 3/4 divided by 1/4. We're dividing a mixed number by a fraction. So the very first thing I want to do, as I've been doing in this entire video, is rewrite this mixed number as an improper fraction. That way we're just dealing with fractions. So 10 times 4 is 40, plus 3 is 43. So 10 3/4 is the equivalent of 43 over 4. And of course, this is divided by 1/4. So to divide fractions, you follow the algorithm keep, change, flip. Uh, K stands for keep, and that says keep this top fraction the same. So we're going to keep 43 over 4 the same. C, which stands for change, refers to this division bar here. We're going to change that from division to multiplication. And flip refers to this fraction in the denominator here. Instead of being 1 over 4, it's going to be 4 over 1. And now we're just multiplying fractions, and we've seen how to do that in this video already. But that said, this is pretty easy to do because we have a 4 here and a 4 here. So I'm going to say 4 goes into 4 one time, and 4 goes into 4 here one time. So technically, this is 43 over 1 times 1 over 1. And as you've seen in this video already, we just multiply straight across. So this becomes 43 times 1 over 1 times 1. 43 times 1 is 43. 1 times 1 is 1. Anything divided by 1 is itself. So 43 over 1 is just 43. In other words, there are 43 servings of almonds in this bag. So that's that one. Number 5 says, Jasmine wants to organize her books in order of the most number of pages to the least number of pages. Jasmine's longest book has 96 pages, and her shortest book has 1/4 as many pages as the longest. If the book in the middle of her shelf has 3 times the number of pages as 3 times the number of pages of the shortest book, then how many pages does the middle book have? Okay, so we're trying to figure out two values here. We have the shortest book here, the middle book here, and the longest book here. And we're told that the longest book has 96 pages. To solve this one, we're going to have to figure out how many pages first are in the shortest book, and then we're going to figure out how many pages are in this book that's in the middle of the shelf. And according to the problem, we know the shortest book has 1/4 the number of pages as the longest book. So that's going to be 96 times 1/4. That is to say, we're going to multiply this whole number by a fraction here. And as always, we're going to rewrite this whole number as a fraction by placing it over 1. And now that we've done that, we're just going to multiply straight across. So this becomes 96 times 1, which is 96. and 1 times 4, which is 4. As you may recall, we can regard this fraction as long division by reading it as 96 divided by 4. In case you can't do that in your head, we're going to go ahead and work this out. 4 goes into 9 2 times without going over. 4 times 2 is 8. 9 minus 8 is 1. Drop down this 6. 4 goes into 16 4 times without going over, insofar as 4 times 4 is 16, and we can see there's no remainder. So in other words, the book with the shortest number of pages has 24 pages. Now we're told that the book in the middle of the shelf has 3 times the number of pages as the shortest book. So to go from the shortest book to the middle book, we're just going to take 24 and multiply it by 3. And in case you can't do that in your head, we'll do it off to the side like this. 4 times 3 is 12, so drop down a 2 and carry a 1. 2 times 3 is 6, plus 1 is 7. So this middle book has 72 pages. Okay? So a few steps involved in this one, but as you saw, it was nothing too difficult. All right, number 6 says, how many 1/8 foot long wooden pegs can be cut from a plank that is 3/4 of a foot long? So for this one, we're going to take 3/4 and we're going to divide it by 1/8. And this will tell us how many wooden pegs can be cut from this 3/4 foot long plank. And of course, we're just dividing fractions for this problem, which means we're going to follow the algorithm keep, change, flip. Keep refers to this top fraction, of course. We keep that the same. Change refers to this division bar. We change it from division to multiplication. And flip refers to this fraction in the denominator. We're just going to flip it such that we have 8 over 1 in this case. Now that we're multiplying fractions, we just multiply straight across. And this becomes 3 times 8 over 4 times 1. 3 times 8, of course, is 24 over 4 times 1, which is 4. 24 divided by 4 is 6. So in other words, 6 wooden pegs can be cut from this plank of wood. So that's that one. All right, number 7 says, on Monday, Mark ran 1 1/3 miles to school, and then 2 1/5 miles to his grandmother's house after school. On Tuesday, he ran twice as much as the previous day. How far did Mark run on Tuesday? So we're going to have to figure out how far he ran in total on Monday. Again, according to the problem, he ran 1 1/3 miles plus 2 1/5 miles. We're adding mixed numbers, as you can see. So the very first thing we want to do is convert these to improper fractions. And we do that like this. 1 times 3 is 3, plus 1 is 4. So this is 4 over 3. Plus 5 times 2 is 10, plus 1 is 11. Plus 11 over 5. And as you may recall, in order to add these fractions, they have to have the same denominators. So we're going to have to rewrite 3 and 5 such that they have a common denominator. That's pretty easy to do since both 3 and 5 share a factor of 15. So we're going to rewrite both of these with a common denominator of 15. To write 3 as 15, of course, you multiply it by 5. We're also going to do that to its numerator. 5 times 3 is 15. 5 times 4 is 20. To write 5 as 15, we multiply it by 3. And we're also going to do that to its numerator. 5 times 3 is 15. 11 times 3 is 33. And now that we have the same denominators, we can go ahead and add the numerators like this. 20 plus 33 is going to be 53. All right, so this is how far he ran on Monday. According to the problem, he ran twice as much as he did on Monday on Tuesday. So to answer this question, we're going to take 53 over 15 and multiply it by 2. Again, we're multiplying an improper fraction by a whole number, so we want to place this. We want to make this whole number a fraction as well by placing it over 1. And now we're just multiplying straight across. So we're doing 15 times 1 here, which is just 15. And here we're doing 53 times 2. So as not to make any mistakes, I'm going to work that off to the side. 3 times 2 is 6. 5 times 2 is 10. So this is 106. Now that we've done that, we have to convert this mixed number or this improper fraction back to mixed number. So this is going to be 106 divided by 15. 15 times 10 would be 150. So we know this isn't going to be 10. 20 times 6 would be 100. So I'm going to say this 15 goes into 106 about 6 or 7 times. So let's go ahead and work that out. Let's start with 7. 5 times 7 is 35. Drop down the 5, carry a 3. 1 times 7 is 7 plus 3 is 7, 8, 9, 10, 105. So this is going to be 7 times 15 goes into 106. 7 times, as we just saw, 15 times 7 is 105. 106 minus 105 is 1. So we have enough to write our mixed number. Again, this is going to be our whole number here. This is going to be our numerator, and this is going to be our denominator. And we can't reduce this any further, so this is how far he ran on Tuesday. If he ran 1 1/3 miles on Monday and an additional 2 1/5 miles on Monday. All right, so that's it for this video. I hope you found it helpful. As I mentioned at the start of the video, these problems are very simple, and they're kind of a bridge between my 30-minute review of fractions and my video in which I work on some very challenging word problems involving fractions. So as always, you're more than welcome to leave feedback in the comment section below. If you like the content I'm creating, please consider subscribing to my channel. Probably tomorrow, if not on Friday, I'm going to upload a video in which I just work on fractions with no word problems, and they're going to be pretty complicated. So that's going to be it as far as fractions go on my channel. So stay tuned if you need some more help with fractions. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.